Hi everyone, in this video I'm going to look at alternative methods to think of algebraic fractions and rationalising denominators. I know a few people are quite confused with what's happening when we're rationalising in a denominator and are then making unusual choices for what they do next. I just want to clear some things up. If you're comfortable with your algebraic fractions and comfortable with rational denominators, I don't recommend watching further. It could cause confusion. Now that said, let's start with the basics. If we have a number on the top of a fraction, the same number on the top of the bottom of a fraction, we have a whole. If we have 2xy over xy, then we have 2. And the reason for that is because we can cancel down by y and cancel down by x. Now where's the confusion, you're asking? Let's have a look at it in a slightly different format. 2 times x times y over xy could be written as 2 over 1 times x over x times y over y. Now you can see quite easily that is 1 and that is 1. So what we've really got is 2 over 1 times 1 times 1, which is why we get 2. Excuse my cat deciding to take a dive over the board. Doesn't like to be left out. Right, hopefully you're all quite comfortable with that. But this is the reason why rationalising the denominator works. If I can get the board to go clean. Ooh, that orange bleeds through a lot. Bear with me a sec. Oh dear, that did not work. Well, we've got a blue and orange board now. Right. If we have, for example, 2 root 2 over root 2, you have been told that to get rid of a root on the bottom, you must multiply by it. And because you're multiplying by it, and it's a fraction, you must do the same to top and bottom. So we're timesing the whole thing by the equivalent of timesing it by 1. What this gives us is 2 root 2, my cat is knocking things over root 2. And you should hopefully know by now that a pair of squares, a pair of square roots, square out. So that gives you 2 times 2 on the top and 2 on the bottom. And we know that 2 times 2 is 4, half that, you end up with 2. Or you can cancel 2 from top and bottom, you end up with 2 over 1, which is always written as 2. Now, when I take that to a more complicated question, I'm noticing quite a few people starting to get confused. So if, for example, I have 10 a squared b c cubed over 5 a b squared c squared. One of the mistakes people are making, they're getting the fractions bit right. They're getting the breaking down of the powers bit right, but then they're getting confused with what to do with the numbers. So I'm not going to show you the mistakes some people have been making. What I am going to do is break this down into its components, and then we'll go through that. So we have 10 over 5 times a squared over a times b over b squared times c cubed over c squared. Now I can break that down a bit more. We can see that 10 divided by 5 is 2. A squared over a, that leaves us just one a on the top. B over b squared, we get rid of the one from the top and one of the ones from the bottom, so we have 1 over b. And c cubed over c squared, we have just one c left on the top. Now when this happens, that's going to give us on the top 2a and c, because times it by 1 doesn't change it. So 2ac on the top over b, because that b is still on the bottom. One of the mistakes people have been making is if it cancels to only the bottom having something, they've been putting that up the top. That's not how it works. If it's on the bottom, it lives on the bottom. It doesn't change where it lives. Now, if you are asked to make it so it's not a fraction anymore, remember we can change that using the reciprocal. So another way that you might see that answer written would be 2a b to the minus 1 c. And that's us without a fraction. Okay? Do one last one with a reciprocal on. Yeah. Getting rid of the third on the bottom. Rationalising the denominator was the term I was searching for. I've got a bit of a migraine at the moment. Right, rationalising the denominator. Let us do a complicated one, far more complicated than you are likely to get in the exam. There we go. Far more complicated than you're likely to get in the exam. So what I'm going to do here, you're not going to get, the c squareds would cancel straight away, so I'm just going to get rid of one of them straight away. Right. There would be two ways to tackle that in the exam. The first would be to cancel down straight away, which you're completely allowed to do. So I could write that as 12 bc squared over root 10, not 12, beg your pardon, 14 bc squared, because I've cancelled down by 2. Or I could write that as, work with it as the 28 bc squared over 2 root 10 and work from there. Now remember, 10 is 2 times 5. Actually, that's not going to make any difference to us in this. I had planned on going somewhere else with this question. Right, let's work it through. So if we have 14bc squared over root 10, we're going to multiply top and bottom by root 10. So we'd have 14 times our root 10 with our bc squared. And that gives us over root 10, which we know is 10. So we've got 14 root 10 bc squared over 10. If we'd looked at the other side, the other method, remember we're only multiplying by the square root bit. We're leaving the number as it is. And that's because we don't need to scale everything up and then have to scale it all back down again. So 28 times in by root 10. And then we've got our letters. And then we times in by root 10. So we've got root 10, which again we know is worth 10 on its own. So we've got 28 root 10 bc squared over 20. Now I'm not done with either of these, because at this point I can cancel further. I've got even numbers here. If it's even, I can divide by 2. And it's only the number portion that gets divided by 2. So I have 7 root 10 bc squared over 5. Now in this one, I could divide by 2, but I can divide by 4 as well. So rather than do 2 and then 2 again, I'm going to go straight to the 4. So 28 divided by 4 is 7. Root 10 bc squared over 20 divided by 4 is 5. Now if you're getting confused about which bits are being divided, another way to think of this is to split it. So numbers wise, we have got 7 over 5. Square root wise, we've got root 10 over 1. We've got b over 1. And we've got c squared over 1. Okay? Think of your numbers and your letters as separate multiplications, and then you'll be able to cross them off easier. Be able to spot where the crosses happen, where the simplification happens. And it'll also stop you from accidentally trying to divide the 10 by 5, because that can't happen. Hopefully that has helped a little bit. If you've watched this and you're even more confused, let me know and I'll try and explain it using examples that have been in test papers.